Okay, so we're now going to look at something called threads. A thread is basically a subdivision of a task or a process. That is the simplest definition I can give you. So a process can further be divided into subtasks or sub-processes which can run parallelly. Each such indivisible subtask is called a thread. So indivisible is the keyword I would like to draw your attention to here. If you take a process, I defined it as one action or one task which you are doing. But again, that task can be divided into subtasks which we are calling threads. But when I am talking about threads, I am mentioning that they are indivisible. So the thread cannot further be divided into a smaller task. So to step away from the computer science angle for a minute, you take the analogy of any task you and I might be doing in the course of our everyday activities. So let's say you're doing a project, for instance, that can be taken as one task or one process. But within that project, you're going to divide it into subtasks, right? You're going to be like collect information, make a report, write code. You will have different subtasks. So those subtasks cannot be further subdivided. So if it says write code, you have to write code. That is one full task. You cannot type half a line of code now and leave the half for later. That doesn't make sense. I mean, of course, if there are interrupts, that is a different context, but generally you get the idea that there are big tasks which can be divided into smaller subtasks, and there are subtasks which it does not make sense to further divide. So the same logic goes with your computers as well. Every function is a process, and when that process is divided into smaller indivisible sub-processes, those are called threads. So processes are divided into threads. Threads are further indivisible. Multiple threads may execute at the same time. So again, we looked at multi-programming, multitasking yesterday, where we saw that more than one processes are being executed at the same time. The same logic extends here as well. More than one threads belonging to the same process or belonging to different processes can be executed at the same time. This is called multi-threading. So we will be looking at threads in a little more detail in one of the subsequent units. So if you're not able to make complete sense of some multi-threading or something like that right now, it is fine. We will be discussing it in more detail. As of now, the core idea I want you to take away is a thread is a sub-process, a subdivision of a process which cannot further be divided. And threads pertaining to the same process share their text, data and heap memory segments but possess dedicated registers. This is an important point to note, both from an understanding point of view and from the exam perspective. This is a frequently asked question. So we know that for every process you have some memory. That memory is divided into text, data, stack and heap. So now when you take a process and you further divide it into threads, does each thread have a separate memory, or do all threads have the same memory? If all threads have the same memory, and if two threads are running at the same time, if both of them access the same memory location, will that not create a clash? So there are these types of questions. And in the fourth unit, where we look at synchronization and related problems, we will be looking at these questions and answers to those questions in more detail. As of now, all I would like you to understand is, when you take text, data and heap, they are common for all threads from the same process. The registers or the stack part alone is separate. So if you go back to here, you have text, data, heap and stack. These three are common to all the threads of a process. So if you have a process P which is divided into three threads, T1, T2, T3, there is only one text segment, one data segment and one heap segment for P, which all the threads can access. But the stack segment, where the registers etc. are stored, that is divided again into three subsections. That is what this point tells us.